Okay, so why do we write unit tests? So in the previous homework, you actually saw what it means to write code without writing any unit tests. You don't have a lot of confidence that your isMoveOK is actually doing what expected. You've done a little bit of manual testing, but obviously not enough. So to unit testing is it very simply it's just an automatic way of doing what you did manually. So manually you wrote a little bit of code to call isMoveOK, and then you checked using console.log to see what the output was. You remember in simple test.html. So with unit tests we can do all this process automatically. So how do we normally write software? You write the code, then you check to see if it works, and if there are any problems, you fix them, and so on. Now, how do you actually check to see if it works, right? So I gave you a simple test.html that you can use, right? If you actually finish building the game completely, you can fire up the UI, right, and actually play the game with yourself and check to see that it's working as expected. Now, um, the the problem is that you may want to check some scenarios that are kind of hard to manually check with the UI. So for example, imagine that you're uh, building a chess game, and one of the rules in chess is that if there is nobody ate a piece in the last 50 moves and nobody moved a pawn, then the game ends in a tie. Now, if you actually want to test it manually, then you need to make 50 moves for the white and black without moving any pawn and without eating any piece, and then check that the game ends in a tie. Now, this is very annoying and slow manual work with the UI. Now, the nice thing about unit tests is that you could actually write it, right? Like just write code that 50 times move the, let's say, the knight back and forth, and check that the game ends in a tie. So that's basically the benefit. Um, now, what happens if you have some problems? So you probably had to debug. So what do you do? So one option is to add logging. That's console.log. Now, the annoying thing with it is that very quickly you're completely spamming the console.log and you cannot find anything there, right? So you keep adding things, and then when you fix the problem, then you actually need to remove it later. Otherwise, people are just spammed with all that logging. So a better approach, if it's a one-time thing, is to use the debugger, and I showed you how to use the debugger. The problem is that, like I said, it's hard to reproduce the scenario. So like with the example with the 50 moves of chess, it's very hard work. Some other scenarios might be even harder to reproduce. For example, if you have some bug report from a user and you don't know exactly what the user did to get to that state. Another option, if like a lot of these corner cases, if some exceptions are thrown, it's kind of hard to find the exact input to throw that exception. So for example, you know that this call with the input 42 caused the problem, but how do you get to that from the UI, right? How do you interact with the UI to exactly cause that method call? So with unit tests, you actually solve that problem by just calling directly object.method with 42 and see that the output is as expected. That's the nice thing about unit tests. You don't need the UI. You can just interact with objects directly. So the problem with all this manual testing that you've done is that it's not reusable. If you need to change some of the code, add a feature, you want to refactor some code, for example, rename a method or a variable, then you want to do all the testing again, and with manual testing, it's just a lot of time wasted. Um, so if you want to add a feature or refactor the code, you just want to run all the tests and make sure that everything just passed instead of manually testing it. So we use testing instead. So the key is repeatability. That means the test needs to be deterministic. So anybody, you and other people, can run the test and see if they pass or not. So it's exactly like the manual testing, but done automatically. And so, right, it's very cheap. Unit tests should take like at most 250 milliseconds to run. So it gives you high confidence that the implementation is correct. It makes sure that future changes don't break old features, and it helps you find problematic code. And you don't need to write like debug with the debugger or use a lot of console.log statements. And you need to test corner cases, exception, errors, and you can test also like complex interactions. For example, multiple users and databases and stuff like that. But in our case, we won't need all that. So we need to test both the good cases and the error cases. So in our case, we want to check when isMoveOK is returning true. That is a good case, right? That you send the expected move, but we also want to have a lot of tests for what happens when the move is illegal. We want to make sure that isMoveOK returns false. Test-driven development is the idea of writing the tests first and only then writing the implementations. So I actually do that whenever I have some bug report in Google or in any of my projects. So if somebody reports a problem, I don't try and fix it. What I first do is try to write a test that reproduces it. And then when I have that test, the test should fail, right? Because there is a problem. And then I just go and fix the implementation, and then I make sure that the tests pass. Now the plus with that approach is that sometimes people first fix the problem, then write a test that they think is fixing the problem, and the test pass, so everything is okay. But they didn't check that the test failed before they fixed the problem, right? And then the test might actually not be testing what you think it's testing. So by first writing the test, you can see that it's failing, and then fixing the problem actually made the test pass. So, right, the test is actually testing what you think it is. So that's the benefit of this approach. The problem is that, well, there is no problem. I like this test-driven development. The problem with giving it to students is that they are not familiar with unit tests, so it's basically giving you the assignment to write the unit test before the assignment to write the game logic. So I tried it in one or two occasions when I taught the course, and the students just got confused. It was too much. So that's why I use the normal way of first writing the implementation and then writing tests. But I believe in test-driven development, and I actually practice it. So next thing, I'm gonna teach you about the frameworks we use. So Karma is the unit test runner. It fires up the browser and then runs your unit tests inside. The unit tests are written in something called Jasmine. So it gives you a couple of functions you can use to define a unit test and to write assertions. And to make sure that your test coverage most of 99% of the code, then we're using Karma Coverage plugin plus Istanbul to what it's called instrument the code. And the important thing is that your tests are simple. So one test is one invocation of isMoveOK, and then it checks if the move is okay or not. That's it. Okay.